So we're going to calculate the thermal expansion of this simple system here. And what it is, it's a 20-meter section of a rail track that is laid, and it's laid at a temperature of 5 degrees Celsius, as you can see right there. And what happens is the temperature increased to 50 degrees Celsius, and we're given the thermal expansion for the metals or for the materials that we're considering. And what we need to do here is to calculate the change in length based on what happened to this system thermally. Now, when we're calculating the thermal expansion here, it's very important that we understand what our values represent. So we have this formula with delta L that represents change in length, and we have this symbol for coefficient of thermal expansion multiplied by our original length and multiply again by our change in temperature. Now, the change in length that we're considering is the change that took place when we moved from cold or a cooler temperature right there to a hotter temperature, as you can see below, where we have that sort of expansion. So what we need to do here is to get our change in length by multiplying our coefficient of thermal expansion, which in this case it's 12 multiplied by 10 to the power of negative 6. And we multiply that by the original length that we have, which is 20 meters. So that's times 20. And our change in temperature here is the difference between the highest temperature that we have here, which is 50 degrees Celsius, and the lowest temperature, which is 5 degrees Celsius. So our change in temperature will be 45 degrees Celsius. And all we have to do here is to multiply all of these, and we end up getting our change in length. So that will give us a value of 0.0108 meters. So that's representing our change in length there. And if we wanted to convert this into millimeters, then we would just simply multiply all of this by 1000, and we'll end up getting 10.8 millimeters. Now, the next video will focus on when we have this same sort of setup, but it's restrained, and therefore stress is induced by the thermal expansion and the rigid structure that's preventing it from moving. So if you want to learn more about that, you should check this next video out right here.